Hi physics students. In this video today we are going to be talking about net forces and how to calculate what we call the net force on an object. It's a fancy way for saying extra force or unbalanced force, but you'll commonly see the phrase net force in physics textbooks. So we know from previous lessons that from Newton's first law that an unbalanced force causes acceleration. So if I have a more force on one side or the other, the object will start to accelerate. Just like with this marker right here, if I let this go, gravity is going to pull it down because there's nothing supporting it upwards. But when my hand is holding it, I'm applying a force upwards that's equal to the force of gravity downwards. I can't do this forever and ever. My arm will get tired and give out, and eventually I will drop it, right? So an unbalanced force is a force that does not become completely canceled out by other forces. Whether that's up, down, left, to the right. We're only in this physics class, we're going to work with just forces going up, down, or side to side. Forces generally don't just go in up and down and side to side directions. Forces are in all directions, but the math becomes much more complicated than that. And if you're really excited about digging into that, I encourage you to come talk to me and we can dig into that together. So here's just a few examples of some pictures. I don't have any forces, but we want to force, remember, force is a vector. So does direction matter? Yes, absolutely. Direction does matter. And, man, I don't have a second person here, but if I just push on this table, it's going to accelerate and move in that direction. If myself and my handy assistant, Physics Pony, here we go. All right, Physics Pony, you gotta push. You ready? 1, 2, 3, push! Man, Physics Pony has a really good firm push. Oh, yeah, we're pushing equal, and this table isn't doing anything, right? There's nothing happening to this table. Our forces balance each other out and cancel them out, and therefore we have no acceleration or no change in our state of motion. So, with these, I do, vector addition. That's just a fancy way for saying adding up arrows or adding up quantities where direction does matter. That if I have two arrows, let's say Physics Pony and I both push, right? Physics Pony maybe is a little taller, can push, is alive actually, and we both push on this table. Our forces add up together and we can push this table harder in that direction. So our total force on the table would be 10, this direction. Same thing if we, just in the previous example, if we pushed with 5 units, I'm just keeping it really simple here, no units, just each pushed with a force of 5, our force cancels out and we have total of 0. If I'm pushing harder, well actually Physics Pony could probably push harder than me if we're being totally honest. Physics Pony is going to push with 10 and I'm going to push with 5. We push for a total of 15. And let's say, oh gosh, I don't have a good example of Physics Pony, but hey, if I push up with 10 and Physics Pony pushes down with 15, these cancel out and we're left with 5 down. Because we have 15 going down, 10 going up, 10 from each of those cancels out, and we're left with 5 going down. Okay? I think when I explain it this way, it helps students really conceptually understand that we're just kind of canceling each other's sides, and whatever's left over is what we call our net force. So in this case, we want to find the net force on each of these free body diagrams. in this first example, we have an object. I have Physics Pony on a string here, and I'm pulling up with 1,200 newtons of force. And Physics Pony weighs 800 newtons. Remember, force gravity is equal to the weight. What's Physics Pony going to do? Physics Pony is going to go up because I'm pulling harder than force of gravity. There is an unbalanced force. And so we have, how much extra do we have going up versus going down? We can just subtract this from this. And so we have 1,200 up plus 800 down, or negative 800, equals 400 newtons up. All right? We have another example here. We have Physics Pony went parachuting and went skydiving. Woo! Pulled their parachute, and force of gravity on Physics Pony is 800 newtons. And the force of air pushing up, now that the parachute, is 600 newtons. Physics Pony will continue to accelerate downwards because there's more force downwards than upwards. And we want to find the net force on Physics Pony. Well, we can say minus 800 newtons plus a positive 600 newtons, because it's going up, equals minus 200 newtons, or 200 newtons downwards, okay? Don't get too caught up in the positive, negative. I think it's important to understand that up direction is positive generally, down is negative. Coordinates are arbitrary. We make them up. There is no plus, minus. That's all a construct that we've made. But that's for another philosophy class with Mr. Magaluk. But I want you to recognize throughout this lesson that we're really looking at just which way do we have an extra force pointing. And that's really the main takeaway that I want you to get from this. All right, last example. Oh my gosh. We have up and down, and we have forces. Oh my gosh. Well, all right, let's break this down. So, we have let's start with one direction at a time. So I'm going to start with up and down. So these two forces, right? Up force is 50 newtons. Down is 50 newtons. So up is 50, down is 50. They cancel out. They actually go to zero, right? And so there is no force up and down, or essentially, right, they balance each other out. And so it's not going to speed up. It's not going to speed up in the downward direction. The only force we have left over is friction. And so our net force in this case is going to be 20 newtons to the left. All right? So hopefully this will help you on your homework assignment. Hopefully I've given you enough information and kept it straightforward enough. But really, we're just really looking to find the extra force on any particular object. And that is what us physicists call net force. Thank you all for watching. Have a wonderful rest of your day.